All right, these are the notes for section 2.1. We're going to kick off chapter 2 today, talking about slope-intercept form and the equation of a line. Some of the ideas, actually most of the ideas today are kind of a little bit of a review, which seems to sort of be the theme for the first couple of chapters, trying to tie things into stuff you guys had from Algebra 1 and Geometry. In chapter 1, definitely a lot about sequences, but we also did a lot with linear ideas, y equals mx plus b. In this chapter, we're going to get away from the sequence idea and focus more on just the idea of the equation of a line and its different forms. And today we're talking about slope-intercept form. Again, I think this will come back to you fairly quickly. So let's get going. Basically, we want to start with some visual ideas, and then we'll get into writing equations, and then tie that into actually something from last chapter, a problem to kind of cap it all off that will take us back to the idea of a recursive idea. So going back maybe as far even as chapter 0, what's the slope, what's the y-intercept, and write your equation, chapter 0 and chapter 1. So this slide really is kind of a quick little review of those ideas tied into one, and I think we all got this down without even thinking about it much at this point. Slope, when you have the visual, is nothing more than a matter of counting. So counting from point to point. And if I do that, starting at the y-intercept, maybe I'll even start with the y-intercept as the first part of our problem. So y-intercept is, of course, the place where the line crosses the y-axis. And then by counting, we should be able to get our slope. So that's a count of down 4 over 1, so we've got a slope of 4. Then the idea is to put these two things into the equation of a line, which we have already done in chapter 1 when we dealt with the idea of sequence, arithmetic sequence compared to a linear equation of y equals mx plus b. The key is knowing what's what, and we should know m and b, because we've already discussed those things. So we'll finish up with our equation negative 4x plus 2. So this slide really just a warm-up, recap, chapter 0, chapter 1, kind of tying all those ideas together. So in Algebra 1, we learned different ways to write equations. Again, the flashback, slope-intercept form is one of them. Point-slope is another one. And standard form. Today we're just going to focus in on slope-intercept. And, again, highlighting things, be a little more specific about it instead of just related to an arithmetic sequence and saying, well, m is the same as d, and b is the same as u sub 0. We're going to kind of set those things aside and just focus on mx plus b. Again, we already know that m is your slope, b is your y-intercept, and these are facts that you guys should have down already. So I'm not going to stay long on this slide. We're going to get right into it, try some examples. So write the equation of a line given a visual. The things I have highlighted in blue and red, of course, are the things you have to have. You can't write the equation of a line without a slope and a y-intercept in the format we're trying to do. So we're going to go ahead and say, well, for starters, let's look at a graph where I don't really have any points and one that does, and compare those two, how we might go about it. First thing I'm going to do, if I look at the graph that doesn't have any coordinates plotted, is just, zero in on the y-intercept. That would be the starting point. And then, I can clearly see the slope. I can run the slope visually as I look at the problem. So start running that slope. Visually trying to run it. And we're there and there. Now, just by counting, down 1 over 2, down 1 over 2. So remember some things about slopes that we haven't spent a ton of time talking about, but I think you guys know is that a negative slope and a positive slope, what's the difference? When you are counting left to right, remember that slopes read, and actually just even graphing generally reads left to right across the page like you read a sentence. So as you count from the y-intercept to the next coordinate, your first movement is down. Well, the first movement is down, and you're talking about a negative slope. Also, we can connect the idea of a negative slope to last chapter in the concept of decreasing. As you look at this equation, as you look at this graph, as you go left to right, clearly the line is, decreasing as we go down, as we go left to right. So we can tie those ideas together. Anyway, writing our equation, pretty easy. Just need to jot a few things down. What is the slope? What is the y-intercept? And then go from there. Y-intercept being at 2 with a slope of negative 1/2 means we've got an equation that is negative 1/2 x plus 2. Again, day 1 of any chapter typically is kind of a little recap and review, and hopefully you guys will find this to be fairly quick and easy. And your assignment today should be one that should be, I think, fairly simple and easy to finish in class. Now the second one, I've got the points there, so I can do the counting idea, and then there's the y-intercept, and sort of got to figure out what I want to do with that. But just by counting, down 5/6, so a simple count gives me a slope of negative 5/6. Again, this is a decreasing. As I look at the visual aspect of it, it's decreasing. That means negative slope. And then the question is y-intercept. Now, what we're going to do here is just estimate. Look at it and go, well, here's what I think it is. It looks to me like it's 1.5. We have ways to be more accurate and be 100% sure. But today, at least for just kind of getting started, the visual aspect of it looks to me like 1.5. So y is equal to mx plus b. Now, usually when I do 1.5, I might do 3/2. You might do 1.5. Either one of those is going to be okay. I kind of like 3/2 because it just sort of looks nice with the rest of the equation. Okay, so I don't think there's anything earth-shattering here. 100% review. What's the slope? What's the y-intercept? Write an equation y equals mx plus b. Let's try a few other things. So given the slope and equation of a line, and a line that passes through a certain point, write the equation. Now I think having the graph actually is helpful here. We can start to plot things out and see what's going on, draw the actual line, and then go back and write the equation. What you don't have in this problem, what's missing is there's no y-intercept. But if we start at negative 2,5 and start plotting using the slope to help us plot other points, we'll see. Hopefully we hit it, or we can estimate it. So let's try it out. So I start out by plotting the point first, and then run the slope down 3, up 3, positive slope, over 1. So up 3 over 1, up 3 over 1. Looks like I'm going to go a little bit off my graph, but just stop and check. So negative 2,5, we got that plotted. Up 3 over 1, up 3 over 1. I'm 1 above where the grid mark is, and that's at 11. So this is 8, 9, 10, 11. Okay. Anyway, I've got the numbers I need now. And, again, I'm going to sketch the line quick just so I've got that there also. So, again, jot a couple things down, slope and y-intercept. Looks like y-intercept was at 11 with the slope at 3. Y equals mx plus b. If anybody's having any issues right now, I'd have to wonder why, right? Because nothing complicated about this. We've already talked about these things both in Chapter 0 and Chapter 1, just to kind of recap that idea. Okay, just a couple more things here. I'll wrap up. Like I said, we're going to keep it short because I feel like you guys know this stuff pretty well already. How about doing an equation of a line that passes through 2 points? Now, we can still do the plotting idea. We can still do slope counting. This time, what's missing is the b. So in comparison, had the slope at a point, didn't have the y-intercept, so I went ahead and just figured that out and counted it. In this one, I don't have the slope or the y-intercept, so I really am missing both of those things. I just have 2 points. But again, plotting to get started, and then counting, all that stuff's pretty visually easy to do. So let's go ahead and check it out. 5, 7 to get started. Negative 3, negative 1. Sketch my line. And then assuming that I've got this drawn accurately, then I can now start to count. And what I'm going to do for starters is count from point to point, and then I'm going to see if that's something that's reducible, and then go back and see how that kind of plays with the rest of my graph and where the y-intercept might be. So just by counting point to point. Now, if you guys think about this, we did this, I told you kind of a shortcut. Instead of counting, tick mark by tick mark or box by box, look at where you are, y. You're between negative 1 and 7. From negative 1 to 7, the grand total of distance would be 8. If I'm at negative 1 and I go to 7, in that space is a total of 8. So what I know is I'm going up 8. On the other hand, your x's are at negative 3 and 5. So if I go negative 3, 5, grand total is also 8. In this case, I'm just really talking about distance. So if it's up 8 over 8, then what that means is I have a slope actually of 1. Now, if my line is drawn like perfectly, then I guess I could count along my line, and it probably also has the slope of 1 if I drew it perfectly. But if you're freehand drawing it, which you guys probably will be, not using a straight edge, then the idea of distance between y, distance between x, is a pretty easy way to make sure you got it right. If I'm saying slope, rise over run, or a positive 1. Now, if I was counting, like I said, and I drew this accurately, it looks like definitely I'm on track there too, so I've got up 1 over 1, and I'm good. And then visually now I can see my y-intercept is at 2, and I got it. Y equals mx plus b. And you notice I didn't put the 1 in because I don't need to, right? So there you go. Okay, just a little bit more here. So then we have some unique kinds of lines, and we're talking about slope, and we didn't really do much with this at all actually in Chapter 0 or Chapter 1, so we might spend just a few more minutes here. But the idea of horizontal and vertical lines and the types of slopes they have and what's unique about them. So we have kind of two sorts of slopes to talk about. We have a zero slope and an undefined. And it's pretty easy to just kind of mix these up. When you look at the two graphs, you go, I'm not sure they both look like they have zero slope or what's undefined even mean. But if you think about slope as, rise over run, then all of a sudden you can start to figure out which one of these makes sense for which graph. This line, a horizontal line, is all run. So what that really means is you have no rise, and you have all run, so I'll say over some number. On the other hand, this one, a vertical line, it's all rise and no run. So that's some number, and no run means 0. Now, if you go 0 divided by a number or number divided by 0, then you should be able to attach them correctly to which thing is going on. This is undefined, this is 0. In other words, division by 0 actually is not possible, right? That's an undefined idea. So we call it an undefined slope or a zero slope. Which one is which? Like, what are the equations? Because that's really what this is actually about, and that's like the equation of line aspect of this. What it says here is a good way to think about how you would write it. So when you do a horizontal line, y equals the y-intercept, and what it really means is that every point on that line actually has the same y value. So as I move up and down this line, the horizontal line, and I check out coordinates, no matter what point I'm at, the y value is the same. So this is 0, -2, 1, -2, 2, -2, -1, -2, -2, -2. Every time I say that, -2 is the y value. So this would definitely be a y equals equation. And again, because the line runs horizontally through the y-intercept, the y equals -2. Vertical, on the other hand, what's true about this is that all coordinates on a vertical line have the same x value. So I start here at 3, 0, 3, 1, 3, 2, 3, 3, 3, -1, and so on. In this case, x equals the x-intercept. So intercepts, again, where I cross the axis. Or again, you could just say, hey, this is the reason you have this type of equation, because all x values are actually identical on that line. So horizontal going through the y-intercept, all y values are the same. Vertical going through the x-intercept, all x values are the same. Okay, let's wrap it up. My last problem for today to kind of quickly tie it back into something from Chapter 1. So if you take a second to kind of read through it, I'm going to read it out loud here. Kira loves to collect her stickers and currently has 40 stickers in her collection. Every day she plans to collect 4 more. So think about what that means. After day 1, she will have 44 stickers. Day 2, she'll have 48. So it's describing, obviously, a sequence. And the sequence is laid out here at the bottom. Use of 0. So we're going to use use of 0 because, again, like collections or an object, where you're starting, that she's had that inner collection already. And she's really saying what happens after that. Day 1, I start adding to it. So that's the 40 is where it's at to begin with. So day 1, day 2, day 3, we see a pattern here. We already know that the idea is adding 4. If that's the case, then my common difference is 4. Really what I want to do now is, again, connect the idea to a linear equation. Same thing we did actually in Chapter 1. And then the last thing it says is using your equation, figure out how many stickers she would have on the 12th day. Okay, well, for starters, getting things going, we've got use of 0. And we've got D, and if you guys remember the connection, D and use of 0, so let's go y is equal to 4x plus 40. And then if you're going for that 12th day idea, that's saying, all right, well then let's go ahead and figure out what's going on when x is 12. How many stickers would I have? Okay, so there you go. They're the notes for 2.1. You guys can use this to do your homework assignment, and that should be good enough.